Hello everyone, this is Miss Sullivan and I am doing lesson 11-2 equations with rational numbers. In the word rational, we see ratios, so that lets you know we're going to work with fractions and decimals. Before we begin, put today's date in the top right corner of your paper. We have our TEKS 8.8a, 8.8b, 8.8c, and 8.1e. Remember the ones, 8.1, anything, are our processing TEKS, so it lets us know what processes we will be using as we go through a lesson. We will be creating and using. I will discuss the other TEKS with you later. We're going to begin this lesson with solving equations where we have variables on both sides of the equal sign, and we also have fractions. But remember, and I want you to know now before we begin, that this applies even if the fraction variable term is on the same side of the equal sign. So I could have 2 or 3 fractions on the left, or I could have 2 or 3 fractions on the right. And if they have different denominators, we're still going to go through this same process. Step 1 says that we need to determine the LCM and multiply every term by the LCM. LCM is the least common multiple. You may be used to LCD, the least common denominator, for when we're adding and subtracting fractions. You can think of it as the same thing. We're just going to find the smallest number that both fractions, the denominators, will evenly divide into. Now, some of you may have been taught the strategy that you can just take the denominators and multiply them together. And when you do that, that's going to give you a common denominator. Now, it may not necessarily be the least. It might be the greatest, or it may be, a larger number. But you can do that as well. So if you're stuck on, what the denominator or what the least common multiple could be or should be, just multiply them together. And then multiply every term by that number. Let's also look at the vocabulary term. What is meant by term is that each piece in a expression or equation is called a term. So for example, 1/4 x is a term. +2 is a term. 2/5 times x is a term, and -1 is a term, or -1 is a term. So each one of those pieces are called terms, and we're going to multiply each term by the LCM. The LCM for this problem will be 20. So in the next line, I put parentheses there without anything in there. And I put it there so that you can see that we are going to multiply each term by the LCM. Remember, if you have a whole number and a fraction, the only thing you're doing is multiplying the whole number times your numerator. So in the next line, we're going to multiply 20 times 1, which is 20, and keep your denominator of 4. Then we have 2 times 20, which is 40. Next we have 20 times 2, which is 40. Keep your same denominator. Then we have a -1 times a +20, which gives us a -20. The other piece that is missing, that is in your instructions, is the simplify piece. So out to the side of the next line, please write the word simplify. Simplify just means that we're going to do any mathematical operations so that we can have our expression or our equation in its simplest form. So that means no math needed to be worked. If I'm looking at 20 and 40, I know that's an improper fraction. So 20 can evenly be divided by 4, and 4 we're going to 25 times. The 40 term is constant. There's nothing to do with it, so I just bring it down. Next, I have another improper fraction in which 5 will evenly divide into 48 times. So that's 8x. And then my next term is a constant term. There's nothing to do with it. Step 2 says we're going to add or subtract to get them on one side. And what that means by them on one side is we're combining like terms. So whichever way you want to move it is okay. You can move the 5x, or we could have moved the 40, or we could have moved the 8x, or we could have moved the negative 20. I'm just choosing to move the 5x. In order for me to remove the 5x from the left, I'm going to have to add 5 negative x's. And when I do that to the left, I have to also move it to do the same thing on the right. When I add those 5 negative x's, I zero out that information on the left, leaving just the 40 term. So that's why the 40 is there, because that's all that's left there. And again, on the right, I'm going to do the same thing. So this time, I'm going to subtract 5 x's from 8 x's, which leaves me with 3 x's, minus 20. I still can't move on to step 3 yet, because when I look at it, I still have two terms that look the same. I have the 40 and the negative 20. They are the same type of terms, which are called constants. And I'm going to move the 20 to the left, because on the left, I'm only left with the 40. So I'm going to leave the 3x, and I'm going to move the 20. If I have negative 20, then to zero that out to get it by itself, I have to add 20 positives. When I do that, it's going to zero out on the right. And so on the left, I have to add 20. Now, 40 plus 20 is equal to 60. And on the right, I'm just bringing down that 3x. I still do not have the variable by itself. I still do not know what it would be for 1x. And the way for me to be able to tell that, I have to divide by the number that is with the variable. Because the 3 is being multiplied, because that means 3 times x, then I have to do the opposite operation, which means I would divide. So I'm going to divide both sides by 3. When I divide both sides by 3, on the right, 3 will go into 3 one time, and that gives me 1x. And on the left, 60 divided by 3 would be 20. So there are 20 3's in 60, and x is equal to 20. We're not finished, because step 4 says we need to check it. The way we check it is we'll just rewrite the problem, but this time instead of me putting the x, I put parentheses there, and I'm going to go through and put in my value for my variable. I said that x was equal to 20, so I will put in 20 wherever I had that variable term or that variable listed. I'm going to go through and do my operation. So 1 times 20 is 20. The denominator remains the same. On the right side, I have 2 times 20, which is 40. On the left, I can divide 4 into 20, and there are 5 4s in 20. And when I look on the right side, I'm going to divide 40 by 5, and there are 8 5's in 20. So on the left, I have 5 plus 2, which is 7. And on the right, I have 8 minus 1, which is 7. Because they are equal to each other, they balance, I can put a check. I know that I have the right amount for my variable. Moving on to example 2. Example 2, we're solving equations where we have decimals with the variable. And again, this could be on the same side of the equal sign, or they could be on opposite sides. Step 1 says that we will multiply every term by the same power of 10 to clear the decimal. So that means we will multiply by 10, 100, 1,000, and so on. How do you know if you should use 10, 1,000, or 100, or, how do you know which one to use? We will determine that based upon the value of the decimal. If I'm looking at 4.5, 4.5 has one number after the decimal, which means it has one zero. So I will multiply it times 10. I would also look at the 5.1, which has one number after the decimal. So I will multiply it by 10. Since they both have the same number of zeros after the decimal, or the same number of numbers after the decimal place, I'm going to multiply each term by 10. And within my problem situation, I will go ahead and put 10 in those parentheses. I'm just working the math on the left. 10 times 4.5 is 45, and that's the reason why we did that. We multiplied it by a power of 10 so that we can get rid of the decimal, and we're working with a whole number value. 5.1 times 10 is 51. Just going through the next steps, I can move either one. I'm choosing to move the negative 51. When I move the negative 51, when I move the positive 51 by adding negatives, it zeroes out. Whatever I do on one side, I have to also do on the other. So 45 from 51 gives me a negative 6. Now I can move on to step 3. Step 3, I'm multiplying or dividing by the number that is with the variable, which is called the coefficient. I'm going to divide both sides by the negative 6. When I do that, negative 6 will go into negative 6 one time, which gets me 1W. On the right, when I divide negative 6 into a negative 300, I get a positive 50. So for this problem, I'm saying that W is equal to 50. Step 4 says we need to check it, so we're not done until we check it. I'm going to check it the same way as I did with my fractions, meaning that I'm going to write the original problem. I'm going to put parentheses wherever my variable was at, and I'm going to now within the parentheses put in the value that I gave for the variable. And I said that it was 50. Now I'm just going to go through and do my math. When I multiply 4.5 times 50, 4.5 times 50 is 225. Then I'm going to multiply 5.1 times 50. When I multiply it, I get 255. On the left, there's nothing else left to do, so I'm just going to rewrite my 225. But on the right, I need to subtract 30 from the 255. When I do so, I get 225. Because both sides are equal to each other, check. I know I have the right value for my variable, and I can move on. And so the TEK for example 1 and 2 is 8.8c, where we have to solve one variable equations with variables on both sides using rational number coefficients and constants. Example 3, creating an equation that models a real-world situation. The first thing we need to do is to identify the quantities involved in the operations. So A, the perimeter of one square is given as 4x. Its perimeter is equal to the perimeter of a rectangle given as 2.5 times x plus 3.75. What is the perimeter of each figure? I'm going to go back through and underline key information. I know the perimeter of one square is given as 4 times x. This square, I drew that, and I wrote P is equal to 4 times x because that's the information that was given to me. As I continue to read, it says the perimeter, its perimeter is equal. So that means I can put an equal sign to the perimeter of a rectangle given as 2.5x times x plus 3.75. This rectangle, I drew that. And I wrote the perimeter is equal to 2.5 times x plus 3.75. I recommend that you always draw. If they give you a shape, you draw it. Whatever information they give you, you write that information. Because they gave me perimeter, I wrote the information on the outside because I know the perimeter is the distance around a figure. So that's why I wrote that information on the outside. My question asked me, what is the perimeter of each figure? Well, in order for me to be able to find the perimeter of each figure, that means I need to know the value of x. I'm going to rewrite my problem, and I have 4x is equal to 2.5 times x plus 3.75. I have decimals, and I want to change my decimals to whole numbers. I have 2.5, which has one number behind the decimal, which means it's times 10. Then I have 3.75, which means I have two zeros behind the decimal, which means it's times 100. Because of the 100 being larger than the 10, I need to multiply each side or each term by 100. Just rewrite the problem to where you're multiplying each term by the 100. I have 100 times 4, which gets me 400. Then I have 2.5 times 100, which would get me 250 times x, plus, when I multiply the 3.75 times 100, I get 375. Now, I'm going to move my 250x over to the left because on the left I only have the 400x. On the right, that means it zeroes out, leaving the positive 375 on the right. So I just bring this piece down. Whereas on the left, I have to subtract, and when I subtract, I will have 150 times x. Next, I have some numbers with the variables, so if I'm multiplying, I'm going to divide by the number that is with it. So I'm going to divide by 150, and I'm going to divide by 150 on both sides. When I do that, on the left, remember 150 goes into 150 one time, getting me 1x is equal to, and when I do the division on the right, I have 2.5. Remember, 2.5 is not my answer for my question. The 2.5 is just the value for x. Now I need to do the next piece, which asks me what is the perimeter of each figure. So that means now in my original problem, I need to go back and I'm going to replace x with 2.5. So in my original problem, replacing x with 2.5. When I multiply 4.4 times 2.5, I get 10. And then when I multiply 2.5 times 2.5, I get 6.25 plus 3.75. Now on the left I have nothing else to do, so I just go ahead and bring that 10 down. But on the right I have to add 6.25 plus 3.75, which gets me 10. And it told me its perimeter is equal to the perimeter of the rectangle. So the perimeter on the left is 10, the perimeter on the right is 10. So actually, if you look at it, we performed our check in order for us to find the perimeter of each figure. So the perimeter of each figure is 10. You always want to write your answer for a word problem situation like this incomplete sentences. And a lot of times that would help you to make sure that you're not choosing the wrong answer choice. Marsha is changing her phone service. One data package charges an initial fee of $50 and 13 cents. And $13.25 per month. The other has no initial fee but charges $25.75 per month for the same data package. After how many months would Marsha have paid the same amount for either package? I'm going to go back through and underline some key information. I know that one data package charges an initial fee of $50 and, meaning I could put a plus sign, $13.25 per month. Per month means I have a variable. The other has no initial fee but charges $25.75 per month. Per month means I can put the same variable, because the first one was first per month, so that means the second one is per month, the same variable for the same data package. I'm going to go ahead and write my information that I have. The key comes in here is, how do you know that you need to set them equal to each other? Well, it's in our question. It said, after how many months would Marsha have paid the same amount? The same amount means that they are equal to each other. So that lets me know that I can put an equal sign. Now I just need to go through and work it out. You have your equation. I want you to go through and work out the equation, and then we're going to start the video back up so that you can see if you have the right answer. And I was just noticing that I didn't write 1325. So let me put my 5 in there. And hopefully you notice that I didn't do that as well. There we go. So once you did all of your work, hopefully you would have seen that after 4 months, Marsha would have paid the same amount for either data package. Make sure you write that in a complete sentence. I bet you're saying, whew, I'm done. Nope, because I'm sure you didn't check it. So I need you to check it. And once you checked it, you should have received 103 on both sides. So check. You know you have the right answer. We can move on to the next question. Example 3, A and B, these go along with the TEK of 8.8a, where we're writing one variable equations or inequalities with variables on both sides that represent problems using rational number coefficients and constants. So that means that our last question has to go with our last TEK, which is 8.8b. 8.8b, we're writing real world situations that can be modeled by an equation. So that means that you've been given an equation and now you need to choose a real world situation that is represented by that equation. We're going to stop the video here for an activity, and then you can come back and see my sample problem that I put. Here is my sample real world situation for this equation. Tanya paid $8.35 per pound for steak at one market. Then she found another market that charges a member's fee of $36.90 a year plus $4.25 per pound for steak. How many pounds of steak would Tanya need to buy for the total cost to be the same? And again, that is just a sample of what I have. You, I'm sure, had a whole lot better problem situations than this one. You guys have a great day. Enjoy your day, and talk to you later. Bye.